Hello students, welcome back. In today's class, I am starting a new topic, that is projectile motion. In your book, it is given in page number 167. Okay, till now we have studied about vectors, addition of vectors and multiplication of vectors and resolution of vector as well. Now, a few of you were asking about syllabus. Now, each and every topic actually is important, but it is not possible to cover each and every topic. So I am just moving on with the important topics, and projectile motion is one of the most important topic in class 11 physics. Now let us study this topic, and will be the last topic from this particular chapter, that is motion in a plane. Now let us discuss about projectile motion. When a body moves under an acceleration whose direction is always parallel to the direction of the initial velocity of the body, then the magnitude of the velocity of the body changes with time, but the direction remains unchanged. This type of motion is called straight line motion. Now the definition seems quite confusing. I'm just writing it the topic. First is straight line motion. Now, whenever we throw an object, suppose in upward, not an object in upward direction, I'll give you another example, that is any object which is acting under the gravitational force or only under the vertical gravitational acceleration. Like suppose you are dropping an object from a height to a ground or the earth's surface. Okay, if you are dropping something from the height, then what happens is the direction is not changing. Okay, the direction is downward from initial velocity. If this is the initial point, the direction is not changing right or left, but it is moving down. The direction is not changing, only the velocity is changing, because over here whatever is the velocity, as it moves down, the velocity increases. Okay, the velocity increases as it reaches the ground, and it is maximum at the surface of the earth. So this type of motion in a straight line is known as straight line motion. This is the simplest possible example to drop anything from a height. Now, when a body moves under an acceleration whose direction is different from the direction of initial velocity, then both the magnitude and the direction of its velocity change with time. Hence, the body moves on a curved path in a plane. Now, imagine any motion in a curved path. This type of motion is known as a curved path motion or plane motion. In a plane, in two-dimensional surface, it will be a plane motion, or it is also known as projectile motion. Now the example for this one will be any object when you throw upward. If you throw an object in an upward direction, not directly up, in upward direction, then what happens? It will move up, it will reach some height, it will again move down. So it has followed a curved path. So this type of a motion which follows a curved path is known as a projectile motion. Okay, motion which follows a curved path is a projectile motion. Right now the direction is also changing. Direction is changing this side, even upward, and velocity is changing at each and every point. Okay, each and every point the velocity is different. Now example in your book is when a body is thrown upward in a direction different from the vertical, then it is acted upon the acceleration due to gravity and the vertical, and it moves along the curved path in a vertical plane. So now whenever you throw an object upward, it also acts upon the velocity whichever you are throwing, and it also is acting upon the force, that is gravitational force, that is acting downward. Now this type of motion is called projectile motion. The path which an object follows, this path is known as trajectory. Okay, this path is known as trajectory. Trajectory is a path followed by projectile motion. Example is a motion of a bullet shot from a gun, the motion of a rocket after burnt out, a motion of a bomb dropped from an aeroplane, the motion of a ball thrown in a horizontal direction, the motion of a ball after hitting a bat, etc. are the projectile motion. The projectile motion can always be resolved into two simple motions, one horizontal and other vertical motion. So I'll draw another diagram. Suppose if you throw a ball in upward direction from here, if you throw a ball, then first of all it will move a straight kind of a path, but after some time it will fall to the ground. Okay, this will be a type of a motion. A ball will follow if you throw a ball. Now each and every point gravitational force is acting. Okay, this point also, at each and every point gravitational pull is acting. The gravitational force, okay, it depends upon the mass of the ball. Now also what is changing over here is velocity. At this point the ball is trying to move in a straight path, so velocity v1 will be in this particular direction. It's now why I'm drawing this type of a line is, now velocity is constantly changing. It is not fixed, but velocity is a vector quantity, so it has to have a direction. So to know the direction of velocity at each point, what we do is we draw a tangent. A tangent is a line which touches the circumference of this curve. Okay, at this point if you draw a tangent, it directs this side. Now if you draw a tangent at this point which shows the velocity, this tangent will direct quite downward. Okay, this velocity at this point is v2. Now the velocity v1 and v2 are different. Velocity v1 is acting horizontally, v2 is acting downward. Okay, not horizontally but quite vertically. Now each and every point, this velocity, when it is not on horizontal or vertical line, this velocity can be resolved into two components to find a final velocity also. Now these two motions, this horizontal and vertical motions, are completely independent from each other. In this figure is thrown a ball with the initial velocity v1 in a horizontal direction. Now under the acceleration due to gravity g, the ball moves in a curved path, which is due to this one because the gravitational force is pulling it downward. And after some time its velocity becomes v2. Okay, after some time its velocity becomes v2, whose magnitude and direction are different from those of v1. So v1 has different magnitude, different direction. v2 has got different magnitude and different direction. So the velocity is different at different point. So similarly, when an object flows in a projectile motion, its velocity and direction keeps on changing constantly at each and every point. Now to find the velocity, the difference of the velocity. Over here what we can see is v1 is horizontal, v2 is vertical. Okay, like this, not vertical but something like this. So this is v1, this is v2. Now how do we do a vector addition? We draw another line which is the final velocity. This will be del v is equals to v2 minus v1. Whichever is greater we will subtract smaller from that one. So del v is the final velocity acting downward. Okay, the velocity is acting downward. So we see the direction of del v is same as that of acceleration. Now acceleration due to gravity is acting downward. Even the velocity, final velocity, is acting downward. This means that the horizontal velocity given to a ball is not affected by the vertical velocity due to g. So whatever horizontal velocity v, this velocity is there, that is not affected to a ball. Okay, it is not affected by the vertical velocity. Therefore, if you drop down a ball from a roof, at the same time throw a ball another ball in horizontal direction, then both the ball would strike the earth's surface simultaneously at different places. So it will not drop together, but it will drop at different time and different place. Now there are a few assumptions for this type of projectile motion. First one is, whenever we are throwing up, there is air molecule, but we are neglecting the air resistance. We are imagining there is no resistance provided by the air. Another one is, the effect of curve of Earth's surface is negligible. Now projectile motion is this one. We will study projectile motion for higher object also, like for rocket, but we are not considering the curved surface of the Earth. We are neglecting the curved surface of the Earth. Another one is, we are also not considering the Earth's rotation. Okay, Earth's rotation is also ignored. And the final thing is, the acceleration due to gravity remains the same up at height reached by the projectile. So at each and every height, g remains the same, which is acceleration due to gravity. It remains the same. We'll continue with the topic. Next one is path of a projectile. Okay, we'll consider a projectile motion and we will find out its path. What will be the type of path and what will be the nature of its path. So suppose a body is projected up with the initial velocity. So before we measure the path, let us first of all draw the axis. This is y-axis. This is x-axis. So a motion is started from this point, which is considered as the initial point O. So initially a object is moving upward. Okay, object is moving upward. It's thrown upward with initial velocity u. Okay, it is thrown upward with initial velocity u. And what happens? It reaches a maximum height at one point, and the object will fall down to the earth. So this will be the type of path, trajectory which a projectile motion has. Now, initially the velocity was u. I am drawing a line because we draw a tangent at each and every point to show its velocity. Initial velocity is u. Angle made with the horizontal is theta. Now, we can resolve this velocity into two components. One is horizontal component, ux. Another one is vertical component, uy. This is what we have studied in resolution of a vector, breaking a vector into x component and y component. So now, after resolving, let us find the value of ux. I have told you many times, the side which is there with theta is always the cos theta. Initial theta will be theta naught. Okay, theta naught. We read as naught. Now this side uy, initial velocity or initial vertical velocity. This x will be initial horizontal velocity. Y will be the vertical velocity. Vertical velocity will be side which is not with the theta is always the sine theta. This we have done in the previous topic, resolution of vector. If you haven't understood, please do check that video. Now the body moves under constant gravitational acceleration g acting vertically downward. So at each and every point the gravitational force is acting downward. That is why the object will fall to the earth. Therefore the horizontal velocity ux, okay, this ux remains unchanged throughout the motion. Okay, ux will remain unchanged throughout the motion due to the vertical velocity g is acting upon it. Only what is changing over here is vertical velocity. This uy is constantly changing. This horizontal velocity is not changing, but only uy is changing. Now let us find the displacement of the body. Okay, few notation has to be done. This distance from O to X is r. this r is known as range of the projectile. The maximum height, okay, this point is the maximum height, which is denoted by h, maximum height of the projectile. Let us mark this point as P. So now each and every point the velocity changes. Over here at this point, let us see what will be the velocity. This is velocity v. Initially is u, then it becomes v. Now let us find the horizontal. Horizontal is a line perpendicular to the horizontal. The angle over here is theta. This side will be Vx. Now vertical, acting parallel to the y-axis. Vertical is Vy. This is vertical velocity. This is horizontal velocity at this particular point. Now at P. At P, what happens? The object moves in a straight path. So it is not moving upward. So at this point, Vy, vertical velocity, is 0. There is only a horizontal velocity, which is v is equals to vx. Only vertical velocity, Vy, is 0. That is why we are only considering Vx. Now at this point, object is moving downward. So V is downward. So we'll first of all draw the horizontal side, which is Vx. Angle between horizontal velocity and V is theta. Vertical is Vy. Okay. So it's enough now. At each and every point, just look at Vx. Horizontal velocity is always in the same direction, always parallel to x. So at every point, Vx is not changing. Okay. But what is changing constantly is Vy. Over here it is in the direction of V, but over here Vy is 0. At this point, Vy is opposite, entirely downward. So what is changing constantly is Vy. Now, with reference to this diagram, we will find out the velocity or the displacement along y-axis. Now the displacement of the body, please write it down, okay? The displacement of the body along the horizontal direction after a time t, okay? Displacement along x-axis will be displacement. The formula for distance is equals to speed into time or velocity into time. Which velocity? If it is along horizontal direction, okay, this is, I'll just write it down, along horizontal direction. So displacement will be horizontal velocity, which is ux into time. So ux is u cos theta not into time. This is x. So now from here, t is equals to x divided by u cos theta naught. Okay, let this be equation number 1. Now we'll consider along vertical direction. Along vertical direction, first of all, let me write you the formula for distance. From class 9, you have studied this formula. S is equals to ut minus or plus half gt square, half at square or gt square, is the same thing. But in this situation, what will be the vertical velocity? What happens to the object? It is falling downward. If you are throwing anything upward, then what happens? The motion is actually directly opposite to the gravitational force. You are not throwing anything downward but upward. So over here in this formula, because it is acting against the gravitational force, this formula will be ut minus half gt square. This minus is because the motion is against the gravitational force. Now Displacement is along vertical axis, which is y-axis. U is the vertical velocity, so uy is u sine theta. So I'll write u sine theta naught minus half gt square, equation number 2. Now substituting equation 1 in 2. So equation 1 was value of t, we are substituting in the equation that is over here. So y is equals to u sine theta naught minus half g. In place of t, I'm writing x by u cos theta naught square. Okay, I'll rearrange this. Okay, I'm so sorry, I have missed one t over here. Okay, t is also there. So in place of t, I'm writing again sine theta naught. In place of t is x by u cos theta naught minus half g x square by u square cos square theta naught. Okay, now sine theta by cos theta is u gets cancelled. Sine theta by cos theta is tan theta naught x minus half g x square by u square cos square theta naught. This is the motion or the vertical motion of the projectile. Now this equation over here, from this equation, y is single y, there is no square, x is square, so y is a linear, x is quadratic. Okay, anything with a square is quadratic equation, x is quadratic, y is linear. Therefore this motion represents a parabola. There are different types of motion: hyperbola, parabola, straight line motion, and so on. This is a parabolic motion, or the path of the projectile is parabolic. So from here we can write, therefore path of projectile is parabolic. So if there is a question in examination to prove the path of the projectile is parabolic, then this is what you need to do. This is what you just have to derive each and everything, explain each and everything, and finally with this equation it is proved that the path of the projectile is parabolic by nature. So I hope this is enough for today. We'll continue with the same topic of projectile motion in the next class with flight time of projectile. Okay, so if there is any doubt, please do ask. This much for today. Thank you.